Welcome to eDNA Tech. In this video, we are going to connect both the LEDs and push button in a Arduino. So previously we have done a separate video for connecting a push button and connecting a LED with the Arduino. In this video, we are going to use both the push buttons and LED. So we are going to run a simulation. So let me make a new workway. So search for workway.com. In it you will have your Arduino simulator. So we are going to use this Arduino simulator. So first we need to have an idea how to get an input and output. So nothing but a simple logic to get a input and output from a pointer variable. We are going to use a pointer star x. So to write the output to the pointer, so we are going to make a address to this variable. So we are going to make a address of some value 0x56. Let us take a 0x56. So after we declaring a pointer variable, this x denotes a address. So we are going to make a value of 0x56 to the x. That means we are going to store this value. If we are going to make a star x equal to some values, let us take 0x ff. That means what we are going to do here is nothing but we are going to store this value 0xff in a given address. So our address is 0x56. So this is the address we are going to store a value. So we are going to store a value of ff in a particular address. This is for output. How to use a pointer to get the input. The same process is only a slight difference from output. First we are going to make an address. Let us take the same address 0x56, and we are going to move this value. So we are going to read that value. What is the value that is stored in the particular address? That means what is the value that is stored in the 0x56 should be moved to a variable or any other variable you have declared. So I am going to make it as a input as a my variable. So I am going to move my value that is stored in a address named 0x56, which is x. So I am going to move what are the values that is stored in the particular address. 0x56 has some data. That data should be moved to my input. So this is the only difference between output and input. So we are going to use this logic to perform our functions. So first we need to connect our LEDs and push buttons. So I'm going to take my LED and push buttons from my components list. So before that we need to get the idea what are the ports we are going to use to connect our LEDs and push buttons. So if you go here, you can see I'm going to use a port C for my inputs and port D for my outputs. I'm going to use two separate ports for my inputs and outputs. You can also use a same ports for input and outputs. For your convenience, you can make any changes. So I'm going to connect a 5 volt to one side of the push button. The other side should be grounded with the help of resistor. So I'm going to connect my resistor. The other side should be grounded. I have grounded my resistors. So the next thing I want to do is to connect my LED. So I'm going to use the port D and connecting my LED at a pin number 2. So you can use any of these pins to connect to your LED. So our connections are over. Now we need to write our program to get an input from the push button, and the output should be sent to the LED. So we are going to write first initialize my port with the help of my function named port init. So I'm going to use a volatile. I have made a separate video what are the use of volatiles, why I used volatile here has been explained there. You can watch this video in that. I have given in the link of that video in the description. You can watch the video and have a clarity why I am using volatile. So next thing I'm going to use the direction registers address. So I'm going to declare a pointer variable named port C direction. So I'm going to use a two ports, so I want to have a two declarations, port C and port D direction registers. So next thing we want to give a address where the direction register is. So I'm going to give a address of 0x to A, I think so. Let me check with my data sheet what is the address of port C data direction register. The port C has 27 and port D as 2A. So I have got the information that the port C direction register as 0x27 and port D direction register as address of 0x2A. The next thing you should write a value in the address which you declared before. So I'm going to write a value of 0x00 to my port C direction register and port D with 0xFF. So why I have written 0x00 is that I'm going to use all these pins. That means these are the port C pins. So I'm going to use these pins as a input. So all these pins as a output. If I given a value of 0, then it shows that you are going to use that pin as a input, and 1 it shows that your pin as a output. So why I have written FF is nothing but a single F is a hexadecimal equivalent of 1111. So there are two F's, that means 111. So it is a 8-bit value which can be written with the hexadecimal with the help of 0xFF. So that means I'm going to enable all the pins as my output. So let me move on to my function which to output my data. So I'm going to write it as output, the same volatile char port D. So I'm going to use the port D, so I am naming my variable as port D out. I have explained here what is the output function. So first we need to write the address and then move this value that stored to the pointer variable. So next thing we should do is that write a address. So port D out equal to what is the address of port D output register. So here you can see the port D data register has address 0x2B. 0x2B. The next thing is to move the value to the port D out equal to what is the value, either a 0x. So if I make it a 0x04 here, if you call a output function, then it will perform only for one pin. So if you making a changes, whether you are connecting this to the pin 3, then you want to change this value here. So we don't want to touch the functions, we want to only change in our main function. So I am going to make it as a variable. So if the variable has a certain value like output data, you can name it as a variable, then you can change the value to the variable, then all it changes. So I am going to declare here a char output data. So what are the value that is stored in the output data should be moved to the address that is 0x2b. So we are going to make it as a general variable. So if the value changes here, then it will pass the arguments here. So if the value is 0x44, then the value is moved to 0x44 here and then here. So we are going to make it as a general variable. The next function we have to write is that character input. So why I'm using in character here means because I'm going to return a value to the external variable, because if I am going to call a function, I should return a value to the some variable. So I'm going to write it as a character because I'm only returning a 8-bit data. I'm using a character there. If your function has extra bits, so you can use the another data type that suits for you. So I'm going to use a port C input, so you can make it as any function. So I'm going to use a pointer variable as my. So I have explained what is the input function. So first we need to write a address, then we should move what is the value that is stored to the another variable. So we are going to get a value through the variable. So we need to introduce a variable named something input data to get our input. So write a function to return your data. So next thing we need is to write a address. So what is the address of port C input? Let us check our data sheet. Port C input as 0x26. So write a address of value 0x26 here. The next thing is to move the data that is stored in the register to the input data variable name. So I'm going to move the value port C input. So what the value that is stored in this variable will be moved to the input data, and then you should return the value whenever this function is called. So I'm going to return the value input data when my function is called. So we are going to move on to the main function. First we need to initialize our port. So I am going to make use of port init to initialize our port. The next thing we should do is that we want to get a input. That means we are going to check our input. What is the input? So I am going to make a variable named button1 for check my input. So button1, like external variable I told before, we want to return a data to the external variable. Here we are going to call a function input. So the function, if I call my import function, then it will check the value that is stored in the input address 0x26, and that will return the data. That means 8-bit data will be returned. So I am going to use the character button1. So what the value that is returned will be stored in button1. So why I am going to use a 0x01 here has been explained in the previous video. Why I am using here AND function with 0x01. So next we need to check while button is 0, button 1 equal to 0. So here you can see I have written a while function to check either the button is initial state. So if the button is not pressed, the value will be 0. So initially we are going to make it as a 0. If the button is pressed, then this button 1 value will be changed, then the loop will terminate. Then we want to check the value of button. So maybe the button 1 value will be equal to 1. So we have connected our button to the A0 pin. That means it will return a value of 0x01. So we are going to check if the button is 1, then we are going to output our LED to glow. So I am going to make it as 0x04. 0x04 is nothing but we are going to send a high to this pin. So this will have a 1, all other pins are 0. So that's it, our program. Let us run our simulation whether our program is correct or not. So now we are going to press the button. If the button is pressed, then the LED should glow. Let us check our program is correct or not. So here you can see, if I press this button, the LED glows. So I am getting an input from this push button, and I am going to make a output with the help of LED. So this is the basic steps how to get an input from a device and how to send a output to the external device. So in the next video, we are going to make 8 pins for our input and 8 pins for our output. The first thing that needed is there are only 6 pins in the port C. We need a extra 2 pins, so we are going to borrow 2 pins from port B, and we are not going to use this 0 and 1 pin of port D because it has a internal function of serial communication. So we are not going to use that 0s and 1. So we are going to borrow another 2 pins from port B for our output. So in the next video we are going to make the 8 LEDs and 8 push buttons to interface with the Arduino Uno. That's it in the video. See you in the next video. Thank you.